Hey everybody, welcome back to a new video. Today I'm really excited to show you guys this product. Now this is a battery box, but it also has a built-in 1000 watt pure sine wave inverter and a built-in solar charge controller. So all you have to do is take the lid off and you bring your own battery. So right here I have the Dr. Prepare 100 amp hour lithium iron phosphate battery. This has 1280 watt hours of capacity and it also has low temperature charging protection. This is an affordable battery. So you take this battery, put it in here, connect up your main positive and negative, and then just screw on the lid and you're good to go. You have a portable 1000 watt DIY power station. Now what's cool about this is it has a lot of your common connections. It has a 12 volt cigarette plug, it has 4 USB ports, including 2 USB-C power delivery ports. You have a lot of DC output high power options on the side, and of course you have your outlet for your AC inverter. Now the crazy thing about this battery box, with all that stuff, it only costs $168. Now when you pair that with a battery like this, that's around $299, out the door you're talking $467 or 36 cents per watt hour. That's one of the most affordable options that I've been able to find so far. So this is kind of a mix between DIY and buy. Now I've been very impressed with all the testing that I've done on this. I've basically treated this like a power station and done a ton of different tests. So in the rest of the video, we're gonna jump into all those tests so you guys can see the true performance of this thing. And I think you guys are going to be very impressed. Now I've gone ahead and assembled everything together. I will break down the assembly process a little bit later in the video, but let's jump right into the testing. Now I did extensive testing on the AC inverter and on the DC output, so let's talk about the AC inverter first. Now the AC inverter is rated at 1000 watts continuous, and you have one outlet that you can connect your load up to. Now I wanted to see if it could run the 1000 watts for 15 minutes without overheating, so I connected up the load and started my timer. Now looking at the output using my oscilloscope, you can see we have a very clean sine wave at 59 Hertz. I was actually very impressed, especially for the cost. Now when taking a look at the voltage, we're getting 112.7 volts output versus the 110 volts that it's rated for. Now the fans on this are very quiet. I measured with my sound meter at 3 feet away and I was getting 50 decibels, and here's what it sounded like. Now during this test, I also looked at the display. It shows the wattage, it shows the voltage of the battery, and it also shows the voltage of the AC inverter. Now after 15 minutes had gone by, the power station ran the full 1000 watts without any issues. Now I also wanted to measure if the AC inverter put out clean power or not, so I pulled out my dirty electricity meter and you can see I was getting 900 millivolts of noise. Now this is actually really good. Most power stations get around 1200 up to 2000 millivolts, so this is one of the best results that I've ever gotten. I also wanted to see what it sounded like with a guitar amp, so I compared the guitar amp plugged into the inverter versus wall power, and this is what it sounded like. Okay, so there's the results for testing the AC inverter. So it handled a full 1000 watts output for 15 minutes, no overheating. The fans aren't very loud at all. We got a pure sine wave output, very clean output by the way, no noise. Pretty impressed, guys. The only thing that it can be critical of is that the voltage was 112.7 volts versus 120, which is what I'd like to see, but it's not rated at 120. So, I mean, it's performing as advertised, and for the cost, I don't think we can complain. In the next section of the video, I want to talk about all the testing that I did on the DC outputs. Now remember, we have a raw battery in here, so whenever you turn this main switch on, you get that raw voltage on all the outputs. Now the benefit to that is that you don't have any regulation, so there's no idle power loss. So whenever you have that turned on, you're not losing any power right here, which is great. Now I tested the output. I got 13.3 volts with my battery load tester, and turning that all the way up, I was able to pull 15 amps or 175 watts. Now, technically you could go higher, but that battery load tester was kind of limited at that level. Just remember, you can't go over 30 amps continuous because there's a 30 amp fuse for all 3 of these connections. Now I did test the USB-C ports with 2 power stations. They were both charging at 30 watts, so they are 30 watt power delivery ports. And I also plugged in a fan and a light into the other USB ports, and I also had the DC output going on the 12 volt socket, and I was able to pull all that power without any issues. Now one of my favorite things about this battery box are the high amperage connections on the side. For example, you have an SB175 good for 175 amps continuous. And this is what an SB175 looks like. These are really common in the RV industry or for overlanding. And if you purchase a pigtail, you can connect right up to this and it gives you direct access to the battery's power inside. There's also 3 SB50s that are gray that are good for 50 amps continuous. So lots of potential here for connecting up high power devices like trolling motors or maybe even hooking up into an overlanding setup. The options really are endless. Now the last connection here is the black SB50. This is for the solar charging input. It goes up to the solar charge controller. Now this unit does have a built-in solar charge controller rated at 10 amps and a maximum voltage of 45 volts. So you want to make sure that your solar panels do not go over 45 volts. Now they also include this solar charging adapter from the SB50 to MC4 so you can connect up your solar panels. So let's go ahead and take this outside and do some solar charging demos. Now I want to go ahead and test the solar charge controller that's inside the battery box. Now it's rated at 10 amps. It is a MPPT solar charge controller and it should put out around 130 watts into the battery. So I have my VCU Tech 200 watt solar panel. We are going to be over paneling it a little bit. This is a tri-fold ETFE design, has 3 kickstands, just a very simple and affordable solar panel. So I have that plugged directly into the charge controller with an inline watt meter. Let's go ahead and see how many watts we're getting. Okay, so here's the inline watt meter. I'm getting 144 watts. Seeing 21 volts from the solar panel at about 6.7 amps, so a little bit overrated power. Now we usually see around 175 watts or so from this solar panel, so we know we're hitting the limit of the built-in charge controller. Remember, this gets full around 14.5 volts, and you have 10 amps going in, that's 145 watts. So that's basically what you'll see max output for this. Now you can definitely bypass this charge controller that's built in with a larger one. So I have some other solar panels and a larger charge controller. Let's go ahead and demo how that works. Okay, so these are my 3 180 watt panels from New Power that I recently purchased. I have them wired together in series and they're going into my 40 amp EPEVER solar charge controller. This is also an MPPT solar charge controller and I'm bypassing the internal charge controller and just going right into one of the SB50 ports on the side of the battery box. Let me go ahead and show you guys how many watts we're getting. Now we're getting around 43 volts from the solar panels. The battery's sitting at 14.2 volts, 28 amps going into the battery, guys. So getting a lot more power. For example, we're getting 400 watts. So pretty awesome to see that much more power going into the battery. Now we do have a bit of high clouds today, so we're not going to get peak performance, but 400 watts, I'll take that on a cloudy day. Okay, we're back inside, and just in case you want to bypass or use a different charge controller than the one built in, I thought I'd talk about 2 charge controllers that I use on a daily basis. Now, the first one is the one that I showed you guys earlier. This is the EPEVER 40 amp model. I really like the display on this one. Now, this one does 12 volt batteries, 24 volt batteries, 36 volt batteries, and 48 volt batteries. So if you purchase this one, you're kind of future proofing yourself because you purchase it for the 12 volt batteries. Well, if you ever buy a server rack system, this will do that. Now this has an open circuit voltage of 150 volts, so you can put a lot of solar panels in series on this, and I've just really liked this charge controller. I bought it about 6 months ago and I use it all the time to kind of top off my batteries. This is not a sponsored product. Now this one here is more like if you want to do car camping or overlanding. This is a dual charger. It has a DC to DC charger in it and also a solar charge controller. You have 2 inputs at the bottom. You plug in your solar panels and you plug in your car alternator charging system and you can charge your batteries. So this one is really cool because it's kind of designed for people that have multi-purpose uses. So I take this one car camping with me. I put it in this case right here and I throw it in the back of my truck, connect it up to my system, and I charge my battery on the go. It also works really well if you don't have sun shining on your solar panels. You can use this to charge up your batteries. Now this is also not a sponsored product. I bought this one a couple years ago and I've used it on all my camping trips and I really enjoy this one. This is the Kisei Abso DMT 1250. I can't remember if I mentioned that or not. This is a 50 amp charger for DC to DC and it does 30 amps of solar charging. So both of these are very high quality battery chargers. So if you are interested in something like that, I'll put the link to both these down in the video description. Now here's a quick look in the top of the battery box. So you have your 1000 watt inverter right here with this protector on it. You have your 10 amp solar charge controller. Over here you have your main inputs and outputs. So you have the SB50 connections and your SB175. You have your main positive and negative wire coming in. The positive goes to this main disconnect or power switch. You have your DC outputs, so your 12-volt socket, your 2 USB ports, and underneath there is a 30 amp fuse. So you can pull 30 amps continuously from this. If you go over 30 amps, you will be blowing that fuse. You have your LCD screen right here, and you have 2 fans for airflow. So really good build quality in here, all the proper wire gauges, and everything is tightened up really nicely. Now, after all the tests that I've done on this battery box, I've been very impressed. I wasn't expecting much for 168 bucks, but the inverter actually puts out really good power. All the outputs, there are so many different ways that you can connect up your devices. And the fact that this actually has a small MPPT solar charge controller built in, that's another plus. Now, I think this checks the box for a lot of the people that are looking for like a slightly DIY project. You know, you do have to remove the lid and connect up the 2 main terminals, but that's it. You barely have to get your hands dirty on this one. So I think a lot of people could handle picking up this battery box and actually, you know, putting it together. Now, I recommended the Dr. Prepare 100 amp hour battery because first, it was super affordable. It has low temperature charging protection, and also it is a high quality battery. I have a full review on that battery and I was able to test it out fully. So pairing it with this, you know, $467 out the door. So 36 cents per watt hour on a 1000 watt power station. So I don't know, guys, what do you guys think about this battery box? Is it something that you guys would buy? You know, I think this would go great with people that are looking for car camping setups or overlanding. You know, it is a little bit bulky, and the display is, you know, has a little bit that it can be improved. There's no actual battery percentage, but, you know, that's what it means, kind of more on the DIY side of things. But for the price, I don't think you can go wrong. Now, here at the last part of the video, I'll show you guys how I put it together. So if you want to see that, stick around. If not, thank you guys for watching. We'll see you guys in the next video. Now let's go ahead and jump into the actual assembly process. Once you remove the lid of the battery box, you'll notice inside a strap that holds everything down. Take your 100 amp hour battery and place it inside the case, and then you want to strap it down tightly, making sure the Velcro is completely compressed. To add a little extra protection, I was thinking about putting a little foam padding around the battery just to keep everything from moving. Now the kit comes with these 2 rubber insulators. You want to put them on your main wire leads before attaching them to the battery. Once those are installed, you can go ahead and attach your main positive and negative wire from the battery box. Carefully slide over the rubber insulators once those are securely tightened. You can then take the lid of the battery box and carefully flip it over and snap it onto the top, making sure to tuck in the wires as you go. To secure the lid down, you have 4 Allen bolts, 1 for each corner. You just screw those in one by one until the lid is securely fastened. Now that's the entire assembly process. It only took me about 5 minutes to assemble everything together, and I'm hoping yours goes just as smoothly. Now all you have to do is charge it up and get outdoors.